Printf can not only print a literal string, it can also format information for us. So if you use %d in the middle of your printf string, then what that means is another argument should be provided to printf and it should produce a number. So in this case, when we run the program, it should print 10 and 10 make 20. So compile it, run it, 10 and 10 make 20. Other things that can go after % include f, which means print the next double, floating point number. S means print the next string. P means print the next address, and we'll talk about addresses in a little bit. C means print the next character. This program is similar, except the numbers that I'm using are hexadecimal numbers. By using a 0x prefix, it means hexadecimal, and that is using the digits 0 through 9 plus A through F. So 1 here in hexadecimal has a value of 16 instead of 10. So this is 16 plus 16. It should print 32 instead of 20. So that's as expected. Let's look at the address example. So %p means print the address of something, and here I'm passing main and printf. Main and printf are of course both functions, but I'm not actually calling the functions. So what this program means is every function resides at a particular address in memory, and it's going to print the address of those functions. This is not generally a useful thing to do, but it provides an example for us. And you see what %p does is by default it uses hexadecimal notation to print addresses. And throughout the course you'll see that we tend to use hexadecimal because it's for addresses, because it's convenient, it's more compact, and it helps highlight often when we write a hexadecimal number that we mean it to be an address, and so it highlights that intent. Not only functions live at addresses, but variables like v also lives in an address. So this program is going to show us v, but first it's going to show us the address of v. Right, it's going to report where that particular v lives in memory. Neither of these programs, the one printing the address of the function or the ones printing the address of the variable, are going to give the same results each time you run it, maybe, or each time you compile on a different machine. You see I got different answers there. So there are certain things that the compiler was doing, like making there be a variable v, and certain things that were decided at runtime, like where that v is located, and seeing the address of things often exposes that. So the way I got the address of v again, I kind of skipped over that, is I used the ampersand operator. A single ampersand in front of a variable means give me that variable's address. Why did I not have to use an ampersand before main or printf? Because the functions effectively get an ampersand implicitly when you use them. I'm going to be drawing pictures like this every once in a while. So these red boxes are meant to display memory of some machine running, right? And most of the locations of memory I don't care about, but one of those locations represents the variable v, and in my program it had a value of 5 inside of it. V itself was at a particular location in memory, and so if there's some other location in memory that contains the address of v, then it will have that number inside that corresponds to the address where v is located. So that's what was going on pictorially in the previous program. Often we'll draw these pictures this way, since the address, the actual number, doesn't matter, can change every time, and so on. We don't want to make up a number necessarily, so sometimes we'll draw it with an arrow from inside this box to the outside of that box to say the value in this box is whatever the address of the other box is.